Hi everyone, this is Gwen from Eve Count Quantum Systems. Thank you so much for sitting through this entire series with us. We are finally at chapter 10, the blueprint or the physical realization. So we've built almost just about a tower of abstract theory, the algorithms, the correction, a lot of acronyms, the information limits, and now we arrive at the full stack question. How do we build this machine? What hardware can actually host this logic? So we're going to mangle this one, but the DiVincenzo criteria, a multi-point hardware checklist. For example, can you isolate the qubit? Can you initialize it? Can you run a universal gate set? Can you measure it accurately? This checklist, and there are other factors, is the bridge between postulates and physical silicon, ions, and superconductors, as well as the many different quantum systems that are currently being researched on across the world. It's actually a fascinating field, and there is something called the hardware race. So the industry is actually still currently in a race between three main architectures. You've got trapped ions, which use individual atoms and lasers, and is considered kind of like a very the precision route. You've got superconducting circuits, which are next, and they use engineered electrical loops or the scalability route, and it leverages the chip industry. And then the last one, or the third one, not really the last one, there's more. You've got silicon qubits that use quantum dots, and it's the integration route where you're trying to use existing semiconductor fabs. So none are perfect yet. Each has different costs and fidelity, and as well as coherence. We have, in fact, at the end of this, reached the end of the series. I know it's been a lot. We've started with a qubit, a vector, and then we ended with a physical machine in a lab. But you now have kind of like a full stack overview, a map of the theory, the speed ups, the noise, what it does, why, the correction, and the physical realization of what can manifest. You aren't just a student of quantum computing anymore. You're already starting to kind of build a bridge between your own understanding and where the future is hidden. So, thank you so much for taking the time to listen to this mini series. And if you've got any questions or any critiques, I'd love to hear them. You can email me at the links below. And hopefully, we will have an in person or maybe like an online series soon. Take care and have a great time learning and going down that rabbit hole of quantum.